Hello class, this is Dr. Viv, and today I'm here to talk about rotational motion, specifically the concept of rolling without slipping. So I have here my various little demo items. This is very common. You've all rolled without slipping, without knowing it probably. Each time you drive safely in a car, the car is rolling on the street, and if you skid, then you're slipping. If you're not skidding on the road, then you're just rolling without slipping. Let's examine some of the basic characteristics of the motion of something simple like a rigid body wheel, which here is this little box containing buttons. So I place it at the 5-inch mark on my ruler, and I'm going to use this as a comparison scale. So I'm going to use the top scale to actually move this wheel forward. So I'll try to do it in a way that does not cause the wheel to slip. So let's see what happens after this top ruler moves the wheel a certain distance. So I want to show you this more carefully. Let's first make sure that we understand that the tens are coinciding here. So the tens, fives, 6, and so forth are coinciding. And now I'm moving this by some distance. Let me move this to 7.5 on the bottom scale. Okay, so the bottom ruler, the movement on the bottom ruler has been 2.5. But the top ruler, let's look at where the 5 mark is. The 5 mark is on the 10, coincides with the 10. So in other words, the center of mass of this wheel has only moved, the initial position was at 5, so the center of mass of the wheel has only moved half as far as the top part of the wheel. The top part of the wheel has moved to 10. This proves that the top part of the wheel moves twice as fast as the middle part of the wheel. Let's try to reverse this motion and make sure that's true. So I'll hold it here, and you can clearly see the top part moving really fast. Now it's back to 5. Let's show this once again. See, the top part's moving twice as fast. So this is one of the features of rolling without slipping. The top part of a wheel always moves twice as fast as the center of the wheel. But what about the bottom of the wheel? So I'm going to say the result first and then try to prove it to you. So what we have so far seen by this simple experiment is that the speed of the top is equal to 2 times the speed of the center of mass, which is the middle of the wheel. And the speed of the center of mass I'll just call VCM. If you look at this progression, you expect the bottom not to move at all. In fact, that's true. The speed of the bottom is 0. But if the speed of the bottom is 0, you wonder how the wheel moves at all. How is the wheel able to move if the speed at the point of contact is 0? Well, the reason for that is actually clear when you actually see the wheel. Let's focus on the bottom part of this shell logo, which has got a little notch here. So if I move this a little bit, that notch is moving up along the wheel. The notch itself is not having any velocity in this direction. It's just going along with the wheel, as it were. because the wheel asks it to move, it's moving. So the point there is only moving because the rest of the wheel asks it to move. It doesn't have any velocity of its own. If that argument seems a little far-fetched to you, I have a better one here. And that would be if you had a wheel. Let's imagine you had a wheel that's simply rolling without any movement. So here's a wheel that's simply rolling like this. So it's got a constant speed. So the top part's going to move in this direction, and the bottom part's going to, so every point is going to have a tangential velocity which is equal to v, and the center of mass itself is not moving, so that's just staying where it is. Now if we were to make the center of mass move, let's say we want to make it move forward with a speed v, what we'd do is we'd add the speed v to the center of mass, and if you add the speed v to the center of mass, you have to add that same velocity to every other part of the I've run out of ink on this one. You've got to add that velocity to every one of the points. So here you can see that the top part now is v plus v, which is 2v. The center of mass point is just v, and this is v minus v because they are opposite direction arrows. So indeed you get that result. So this is one of the surprising results of rolling without slipping. The top part of the wheel of anything that moves twice as fast as the rest of the object. So there are portions in your car that need to be ticketed by the cop, because even though your car is doing 60, the top parts of the wheel of a car are doing 60 and above, and specifically the topmost part is the biggest offender. It's actually doing 120 miles an hour on a 60-mile-an-hour highway. So